Hello, hungry learners. Welcome to the Storytelling Science Lab YouTube channel. In this episode, we'll talk about designing an ecosystem, including the ecosystem pyramid and information about planetary tilt, orbit, and how that affects weather on a planet. With all that said, let's get right into it. The ecosystem pyramid. This pyramid represents the hierarchy of your ecosystem. It's a helpful visual aid in designing an ecosystem and also understanding real ecosystems here on Earth. If you don't live on Earth, you can use it to model the ecosystems on your planet as well. At the base of the pyramid is always plants and basic life forms. Plants take energy from the sun, the host star, and they turn that energy into sugar and oxygen. This oxygen is then used by animals and more complex beings that are unable to generate sugar from photosynthesis. They eat the sugar and utilize it for movement and for development of their own bodies. At the base of the pyramid has to be plants. There can't be life on a planet unless there is something that everything eats, ultimately. I call this level the passives. Anything that falls into this category doesn't specifically eat any other organism, usually digests something like sunlight or geothermal vents. It has to get its energy from a source that's exhaustible, but so immense that it would never run out for the lifespan of the organism until it goes extinct. Next on the list, on the pyramid, would be the herbivores, which directly eat plants. Herbivores are animals such as cows, deer, anything that exclusively eats plants is an herbivore. There are large herbivores like whales, which eat plankton to grow. Examples of small herbivores are squirrels and rabbits. Next on the pyramid is the omnivores. Omnivores are animals such as raccoons and chickens. Often an omnivore will have a preferred meal, such as meat, and if there's no meat available, then they'll eat plants. If they prefer plants, they'll often not eat meat, but they can if it's available, easily accessible. Next up on the pyramid, at the very top, is the big P. This is where predators lie, also known as carnivores. They are unable to digest plant material to create energy. Predators feast exclusively on omnivores and herbivores. Omnivores usually would be predatory to other herbivores, but it's possible that an omnivore would be able to beat a predator depending on the size and the species of the omnivore. They may be able to win in a fight. However, it's often fairly rare for an omnivore to go up against an herbivore since they tend to be more shy. In terms of biomass on a planet, the passives would comprise the largest portion of biomass. As far as actual numbers, if it's large biomass, like each individual is very large, such as large trees, their numbers would be lower, but their biomass would still be very large compared to the herbivores, which would be the next largest population size in terms of actual biomass. And then after that would be the omnivores, be the next step. And then predators. Predators comprise the smallest size in terms of biomass. If you were to design a very large predator, you have to take that into consideration. Their population would be very small. It's not common for very large predators to exist on Earth. Some planets may have very large predators, but they would have to have appropriately large size and biomass of herbivores and omnivores for them to eat. Otherwise, they would have gone extinct a long time ago. Ultimately, every step of the pyramid is dependent upon the sun or geothermal or whatever the key power source to provide for life is on your planet. Most planets, it is the sun. Most planets have abundant plant life and a breathable atmosphere. The atmosphere may be toxic to species not native to the planet if there is elements in it that are toxic, but any planet with plant life that takes CO2 and makes oxygen would theoretically be breathable in that way. How orbit and tilt affects weather. In all likelihood, your planet is far enough away from your star so that you can consider the light coming from the star to be parallel. It's not quite parallel, but it's very close to it, which means that the sun is a deadly laser. Anyway, Earth's tilt is around 15 degrees compared to a line if you drew it perpendicular to the plane of its orbit. At this point in its orbit, it's summer for the southern hemisphere, winter for the north. That's a bit extreme. That's better. This point, it is summer for the northern hemisphere, winter for the south, fall and spring for the people at home. So the reason that it's summer for the northern hemisphere here is because the northern hemisphere experiences more sunlight. As it rotates, more surface on the northern hemisphere is in contact with the sun at one time, which heats up the northern hemisphere, and less sun is in contact with the southern hemisphere, which lets it cool off. So it gets cold in the winter, hot in the summer. We all know that, didn't we? What happens if the tilt is more extreme, though? In the case of a planet whose tilt is close to 90 degrees, well, it's quite a different story. On Earth, we have places that experience full sun days or multiple weeks where it is nonstop sunlight in the North Pole, around the Arctic Circle in the summer, nonstop sunlight. In the winter, nonstop night, there's no sun. The opposite's true for the South Pole. The same is true for the South Pole, but it's opposite of the North Pole. So in the summer for the South Pole, constant day. On this planet, this hypothetical planet here, at this stage in its orbit, it would be full sun for the southern hemisphere and full night for the northern hemisphere. Opposite side, of course. The opposite's true. Depending on how long the orbit is, if it's, say, 100 times Earth years, then this would be a 25-year stretch of constant sun for the southern hemisphere, which would be absolutely brutal for any would-be ecosystem on this planet. I've devised a feasible ecosystem, which I'll discuss later in the video. What does this mean for ecosystems? What this means is that the ecosystem would have to either constantly be changing and adapting, or be so rugged and durable that it can survive both the extreme summer and the extreme winter. The simplest way would just be plants and animals that are really tough, or plants and animals that migrate. Another solution that I came up with was to have a plant that during this quarter of the year is a tree, big, strong tree. Its seed doesn't produce another tree, but instead produces a shrub. And then as the summer goes on, the shrub produces a seed that makes a cactus, able to resist the extreme heat. And mind you, unlike cactus on Earth, which close their pores during the day to conserve water and only produce their oxygen at night, they are unable to do that on this planet because it is constantly daytime during the summer. And so it would have to perhaps wait for a cloudy day to release its oxygen, but that's not very feasible. So some other method of conserving water would be required for this cactus. Then after the cactus, it produces a nice long vine with lots of leaves that grows a bulb, and that bulb lasts through the winter. It's just a big hard bulb with an insulative layer so that the internals don't freeze for the long winter. After the winter's over, then it grows into a tree. You could have birds on this planet that migrate from place to place, eating the seeds of the trees and the shrubs and the cactus. They wouldn't have to stay in one place and be so beholden to the long summer they would be able to migrate away from it and be in a cooler environment. They also wouldn't have to stay in the long winter either. They could stay around the equator most of the year, and they would be healthfully fed by all the seeds that these plants produce. But that's just one solution. I hope this video helped you in designing your own ecosystem and coming up with your own solutions, and helps you to think creatively about your next science fiction project. Thanks for watching this video. Stay curious, stay inquisitive. Thank you to my video editor and for all our supporters, people who make this channel possible. Have a good day, and I'll catch you in the next one.